Good day, folks. This is video number 5 for the playlist, which is dedicated to motion design application in the 3D Experiences platform. But the particular playlist which deals with the kinematic aspect, because there's a second one, motion design with dynamics problems. But this particular tutorial, this particular video belongs to the kinematic problem. Now, here's the situation. We have a block which is sliding down a track according to a prismatic joint configuration, and we have a prop on the top, or you can call it arm if you want, which is turning, and the dimensions are given here, but these dimensions are just for your convenience. They don't play a role here, but I'll stick to them. And the method that I'm going to use to provide the information on exactly how the motion of the block is and the prop is given by what is called data points. Let me remind you that in order to simulate these things on 3D in 3D experience, you have to create drivers, and in the drivers you have to basically give the rules of engagement, and I'm going to be using data points. Okay. Uh, the information for the motion of the block as a function of time is given according to this graph, and for rotation of the arm or the prop on the top as a function of time in terms of degrees is given as you see down here. Once again, I remind you that when it comes to doing these things in uh, motion design application, you have to create drivers, and drivers basically they used to be called commands, but you have to give it drivers, and the physics of the driver is going to be specified according to one of these. Frankly speaking, I could not find uh, the functionality which you actually type a formula. Maybe it's there, but I couldn't find it. Whereas that is available in the mechanical systems design and mechanical systems experience, different playlist. Okay, so we're going to be using the data points in this dialog box. We'll see that. And this is not the only way of solving these problems. Okay, so let's go ahead and do that. I'm going to start with assembly design. Okay, good. And insert the first part, which is going to be the track. Let me call this thing track. And track. And I'll stick to those dimensions, although they're totally irrelevant. Double click on it. On a convenient plane, on that vertical plane, I will sketch. We'll sketch perhaps something like this. Let me make this thing 1 inch, and the side I'll make it 0.25. Exit, and then pad it by 11 inches. Then we're going to insert. The block. Insert 3D part. Let me call this thing the block. Block and block. All right. Let's go in it. On that same vertical plane, I will sketch a square, size 1 by 1. So this dimension being 1, and this dimension also being 1. Okay, exit. and pad it by 1 inch. Let me change the color of that thing. Properties. I'll change it to maybe green. All right. Now on top of that, I will draw a circle because that's where the prop is going to go. So let me. The actual size of it doesn't matter, but what I want to do is I want to make sure that this is exactly at the, again, not relevant, but it looks nicer. This dimension being 0.5 and this dimension also 0.5. It's exactly at the middle. Exit. And pocket it. Fine. So this is where the propeller is going to go. Now we go all the way to the top in the assembly. Insert the last part. Insert 3D part. I'm going to call this thing the arm or propeller. Arm and arm. And I'm going to change the color to be orange. And let's go make it. Double click on a convenient plane. On this plane, I will sketch. Because I'm lazy, I'm going to project that circle. Actually, no, that's okay. I'm not going to project. Oops. Okay, let me draw the roughly something that looks like that prop. And of course, I can make dimension from here to here 3 inches, but okay, let me do that actually. Totally irrelevant. Fine. And exit and pad in the other direction by maybe 0.2. There we are. Okay. So here's the situation. Now let's assemble this thing because I'm going to create the joints first, and which are automatically going to be converted to in the motion design. So we go to all the way on. We go all the way to the top, assembly design. Let's fix the track. The track is fixed. Let me make a prismatic joint. Prismatic. I'll use this template, but it's totally irrelevant. This and that. This face and that face. And I don't need this last option. I just close it. Then I'm going to make a revolute joint. Revolute joint. I'll use this one again. It really doesn't matter. Axis to axis, plane to plane, and then I don't need to create a controlled entity there. So this axis and that. Actually, let me try it again. This one, that axis and this axis, and this plane and that plane. There. And I don't need this last option, just delete it. Okay, so it looks like we are good. We have one prismatic, one revolute, and let me update this. Good. Now we're going to go to motion design. Remember, I've done a whole whack of these using mechanical system design and mechanical systems experience, but I'm using this tutorial with motion design. You click on it. What happens is going to create a mechanism for us. Notice that we didn't have a mechanism, but now it's going to be created. And here's the mechanism has been created. Because I'm doing a kinematic problem, this gravity doesn't do anything. there are three bodies here. There's the ground, which is automatically created by 3D Experience. There's the track and the block and the arm. And then there are joints, prismatic, revolute, and fixed. And that's it. Now, we're going to create drivers. So what does that mean? If you look in the mechanism tab, you're going to find drivers here, a driver. Click on it. It says, okay, first driver. What do you want it to drive? I want to drive prismatic joint. Okay, and then we're going to specify how through a function. You click on this, create a new function. Oh yeah, and then we want it by from data points. And notice that what I have to do is I have to input, how many points is that? 1, 2, 3, 4 points. Okay, so let's go back here. First one is 0 and 0. By the way, I don't want this thing to be angle, I want it to be length because it's a prismatic joint. Okay, and then to add an extra row, another row here. At 2 seconds, this is going to go to be 8 inches. Another row at this at 4 seconds is going to be 8 inches. Look, 4 seconds, 8 inches. At 6 seconds, also 8 inches. Also 8 inches. And the last one is at another row at 10 seconds is going to be 0. The only thing is that it's doing this graph doesn't look what I have because it's doing natural cubic spline. I don't want it. I want it to be linear. This graph that you see here is that graph on the top. Okay, good. And then we say we may have to come back. We may have to come back and do something with this scale. We may have to put a minus sign here. We'll see. We say okay. Let me say okay. Then another driver. But this time for the revolute, and then we're going to provide the input to it. Move it on the side. Now this one is angle, but I want it to be again from data points. First one is 0, 0. That's this graph that I'm talking about. Then at 4 is 720 degrees. So another row. At 4, it's 720 degrees. Another row. At 6, it is also 720 degrees. And another row. At 10, it is 360 degrees. Okay, and we don't want to see it as a cubic natural cubic spline, linear, and this graph that you see here is exactly that graph. Okay, very good. And then we say, okay, we may have to come back, and if the direction of rotation of this propeller matters, then we may have to come and reverse it, for example, by putting minus sign in the scale. So it's okay. Now, let's check it out. First of all, if you click on the kinematics player, you see two sliding bars here. One of them controls the motion of the block. The other one, the motion of the propeller. Not according to physics, but we can just manually move them. Okay, good. All right, notice that automatically, when we created the mechanism, a case was created, and down here, a dynamic step is created. Left double click on it. This is not a dynamic problem, it's a kinematic problem. So I select this, and I want to go over a 10-second interval, and I want to extract wait a minute, something is, whoa, it's terrible. Position, velocity, and acceleration. You say okay. Okay, you can preview it, and if it goes in the wrong direction, we may have to go and fix the scale by putting a negative sign. So let me preview it first. This is not running it, just previewing it. You see, it's going in the wrong direction. So we go back, Let's go back to that driver. You can go either to the driver for the prismatic one, or you can go to the function that is created for those things, or not function, but the data point. Either way, let me double click on data point. It'll take me there, and under scale, you put a minus sign here, and it will flip it. Hopefully, it'll go in the right direction. Let's check it out here. Try the preview. That's what I want. Again, if the direction of the rotation of the propeller is not good, then what you should do is you should go back and put a minus sign in front of that f of x also. Now, let's go back. I'm going to run it. So simulate it. You go to simulation. Here is the run analysis case. Wait until this thing finishes. Now you can go and go to results, select the last line in the results, and say, show me the animation. I mean, not a big deal. We're going to see whatever we did before. Stops there, and it goes back. Okay. And if you want to look at the plots, for example, if you want to see what is the angle swept by that, for example, the propeller, so what you do is you go and select the revolute one, and then show me the position rotation there. And this is the same graph that I inputted. If it doesn't come out to be the same, you have not inputted the correct thing. You can also, by the way, put velocities. The velocity is going to be constant, 0 and constant. So for example, if I kill that, velocity, rotational velocity, constant, 0 and constant as we. Now if you want to look, let me get rid of this. If you want to look at your prismatic joint, here's the prismatic joint, a position, this graph is exactly that, except that I flipped it because it was going the wrong direction. And there are situations, I haven't seen it in motion design, it is possible to flip the direction of the motion in 3D, mechanical systems experience and mechanical systems design, but I have not seen it in this motion design. It may be buried somewhere that I couldn't find. One last thing that I want to remind you of is that notice that here is my assembly. This is my assembly, right? This is my assembly. If you want to put that animation video in the assembly, because people may not have the license, for example, to 3D motion design, but they still want to see how it is in the assembly. So what I can do is I can go back here. You see, you go here under results, export animation. See that? Export animation. I have to select it first. Select export animation. And let's go back here. It's right there. I don't think we had it there before. I'm not sure, but anyway, I don't think this requires the license. But you can, if you have the license, you can do it in motion design and then export it here. This is something can also be done in the mechanical systems experience and mechanical systems design. All right, folks, good luck.